Hello dear students, I Abhinav Sir welcome you all in the faculty driven platform that is Resultant. As you all know guys, we are here with the Game Changer series, and in this Game Changer series we will be doing today soil mechanics. Okay, in this Game Changer series guys, let me remind you, or if you are joining us for the first time, that all the topics from where maximum time the questions have been asked in previous year, all those questions will be taken. Okay, so today will be soil mechanics guys. Moving forward, please like the session and share with all your friends so that maximum students can join. I hope audio video is fine. Let me check in my mobile. Yeah, it's fine. Okay, those who are new in the channel, let me introduce myself. My name is Abhinav Sir. I have done my MTech from IIT Delhi in geotechnical engineering guys. Okay, the same subject I will be taking today. Okay, you can join me in my Telegram group, Civil by Abhinav Sir guys. More than 6,000 students have already joined this platform. You can join for all important civil engineering content and important updates. Hi Sachin, Jaya, Arna, Chaitanya, good evening, good evening, good evening. Ready? Guys, please have a pen copy with you. Pen, copy and calculator with you guys. Okay. Come on, come on, come on. And let me tell you guys, all the students, okay, who are preparing for GATE 2026, I'm starting a new batch. This will be starting on 19th of December. Okay, that is Thursday at 5 p.m. You can download the Resultant Civil app and join this batch. Okay, so this is the Game Changer series schedule. Som we have already done. If you have not seen the yesterday's session guys, please watch that. Today we'll be taking soil. Again I am taking soil plus foundation, both will be done. Okay, and most important topics questions will be done guys. MSQ, NAT, everything will be done. Some questions will be previous year questions and some questions will be my own questions. That or similar type of question can be asked this year as well. Okay, if you're preparing for GATE 2025, you can join our crash course. You can buy our crash course guys. You can download the Resultant Civil app from the Play Store and get this crash course. Okay, so if you want to connect me regarding any doubt, regarding anything guys, you can connect me at this my mobile number 93549 or you can mail me at abhinav@resultant.in. If you are preparing for GATE 2026-27, then we have the complete course. See, this crash course is for the GATE 2025. If you are preparing for GATE 2026 or 27 guys, we have a complete course where live plus recording classes will be there. For every subject we have study notes PDF, for every subject we have workbook, for every subject we have previous year question PDF, for every subject we have formula book. Okay, study notes for every subject, PYQ for every subject, workbook for every subject, formula notes for every subject, that you can download for lifetime. Okay, so you can join our course. Okay, that for GATE 2026 and 27. Good evening Arna. Okay, this you all know yaar, how to download the app. Shall we start with the question guys? First question is MSQ. First question is MSQ guys. Hit the question hard and let me know your answers on the comment section. Let me know your answers on the comment section. For a rigid footing placed at the ground surface on sand, okay, it is sand, how the contact pressure will be looking? How the contact pressure will be looking for a footing which is on sand? Okay, for a footing which is on sand, how the contact pressure will be there in case of sand? Okay, this is important because clay will be having a different diagram. This is sand. Let me tell you guys, for rigid footing, first of all you should be knowing, for any rigid footing, settlement will be constant and contact pressure will be different. Okay, whether contact pressure will be different, whether it is on sand or clay. If it is a rigid footing on sand, or rigid footing on clay, rigid footing on silt, anything, then settlement will be constant and contact pressure will be different. If it is a flexible footing, okay, if it is a flexible footing, guys, voice is not coming kya? Okay, audio, okay, video is stuck I guess. Okay. Let me fix it. Let me fix it. Let me fix it. Let me fix it. Okay. Yes, yes, yes. Let me fix the video. Just give me a 2 second, guys. Just give me a 2 second, guys. Hello, 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 hello. Just 2 seconds. Is fine. Now everything is fine. You can check. Okay. 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 Now it's fine, na? Yeah. See, I am becoming technical expert also day by day. Audio तो आ रहा था ना? Okay. Now, thank you. Thank you. So, guys, for rigid footing, settlement is constant. Contact pressure is different. For flexible, it is reverse. For flexible, settlement may be different. Settlement may be different, but contact pressure is constant. Okay. So this is a rigid footing, so it will settle to here. From the vertical downward loads from the superstructure, it will go here. It will go here like this. Settlement is same. See, here also, here also, here also, settlement is same. But contact pressure is different. How the contact pressure looks for sand? For sand, the contact pressure is something like this. For sand, the contact pressure is something like this. So it is maximum at the center, A is correct. It is 0 at the edges, and this distribution is parabolic. This distribution is parabolic. So it will be A, B, C. Give me yes or no. Give me yes or no. Audio is fine now. Audio is fine now. Audio is fine. Come on, come on, come on. Let's move to the next question, guys. This has been asked in GATE 2002. This has been asked in GATE 2002 in 1 mark. If there will be some disturbance in audio, you can tell me, guys. Battery तो full है यार वैसे हाँ full है. Battery तो full है. Okay, कुछ disturbance होगा audio में तो बताना. Somebody has just WhatsApp me about the audio. Video we have corrected. Soon I will not be only civil engineering expert but also this video expert as well. Okay. Now, what is the liquid limit? Guys, when we draw the graph, okay, in the Cassegrain apparatus, once we draw the graph, okay, in the Cassegrain apparatus, once we draw the graph, in x-axis we represent water content, here we represent log n is the number of blows to close the groove, number of blows to close the groove. This becomes a straight line, and this is a decreasing straight line. This is a decreasing straight line. Why decreasing straight line? Why decreasing straight line, guys? Obviously, very simple. When water content is high, less number of blows are required to close the groove. Na? Soil will be slurry, will be very, very wet, will be very liquid. So with less number of blows, the two ends will be closed. When it is dry, more number of blows will be required. So it will be a decreasing graph. When the water content corresponding to 25 number of blows, the water content corresponding to 25 number of blows is called as liquid limit. So corresponding to 25 number of blows, 61.9. See, easy question here. Easily, this has been asked in GATE. This has been asked by GATE, 61.9. Now let me tell you one more thing. This has been asked in previous year. This time they ask, what is the slope? What is this slope called? What is the slope of this graph called? Slope of this graph is called as IF, that is flow index. Okay, and larger is the flow index, lesser is the shear strength. Larger is the flow index, lesser is the shear strength. Yes or no? Yes or no, guys? Come on! Come on! Everyone. Okay. Now moving forward. The undrained cohesion of a remolded clay is 10 If sensitivity of the clay is 20, this has been asked in GATE 2004, 1 mark question. Okay, sensitivity is 20. What is the corresponding compressive strength? What is the corresponding compressive strength? We know that for the compressive strength, guys, the graph will be compressive strength. We are applying the load only in one direction, that is compressive. Okay, that is QU. That is also called as, this QU is also called as unconfined compressive strength. Unconfined means one of the principal stresses is 0, and here we are applying the load QU, or it is called unconfined compressive strength. As it is mentioned, it is clay. As in the question, it is mentioned as clay. So the more failure envelope will be something like this. So this is the cohesion. Cohesion is radius and QU is diameter. So QU diameter is 2 times of radius. So 2 times of 10, that is 20. That is 20. So nothing to do with sensitivity here. Nothing to do with sensitivity here. Yes or no? Yes or no, guys? Come on. Come on, come on, come on, everyone. Got it, Nikita, Chaitanya, Jamim, everyone. Let's move forward. Shall we move forward now? Okay. Now this is a MSQ, not the previous year question, but from the shallow foundation, guys. Mainly the questions are asked from Terzaghi and Skempton. Mainly the questions are asked from Terzaghi and Skempton. The net ultimate bearing capacity, Q and U. Net ultimate bearing capacity. What is the difference between QU and QNU? In QU, the bearing capacity is calculated including the self weight of soil. But in QNU, the bearing capacity is calculated only of the superstructure, excluding the self weight of soil. So QNU is QU minus weight of soil, gamma dF. Okay. Okay, guys, come on. Yes. So unconfined compressive strength is 50. We just have studied this here. UCS is 50. So what will be C? C is UCS by 2. That is 25. Now the bearing capacity is asked for a square footing. For a square footing, the catchword is square and it is clay. Square and clay. Square and clay. So first of all, let me find for this Terzaghi. Terzaghi भाई साहब ने क्या कहा था? Terzaghi में J नहीं आएगा, Z आएगा. It will come Z in the spelling. So it will be CNC for clay. It will be CNC for clay, but it is CNC is without shape factor. Here it is mentioned square. Here it is mentioned square. So we'll apply the shape factor 1.3 CNC. So 1.3 into cohesion is 25 and NC for phi is equal to 0. For clay, what is the value? For clay, what is the value of NC? It is 5.7. So please check, is it coming 185.25? So this will be correct. This will be wrong. Now for Skempton, let me do Skempton here, otherwise it will be behind me. What is the formula for Skempton? Skempton says easy formula. For every footing it will be CNC. But yes, NC will be different for every shape. Okay, like for square, the NC value is given by 6 into 1 plus 0.2 depth of foundation DF by B. Okay, so what is the value of C? C is 25 into 6 into 1 plus DF will be 0. DF will be 0, guys, because it is on surface. So depth of foundation is 0. It is in the surface itself. So it will be 150. 25 into 6 is equal to 150. So A. So answer will be A comma D. For this MSQ question, answer will be A comma D. Come on, everyone. Correct? Okay. Now next question. The ratio of saturated unit weight to dry unit weight is 1.25. So we know that Gamma, this has been asked in GATE 2004 in 1 marks. Gamma sat is G plus E 1 plus E into gamma W. And what is other? Gamma dry. Gamma D is G gamma W upon 1 plus E. Now dividing both of them. Gamma sat divided by gamma D. This is 1.25. Once we divide both of them, gamma W will be cancelled, 1 plus E will be cancelled. It will be G plus E upon G. So from here 1.25, what is the value of G? 2.65 plus E upon 2.65. One equation, one unknown. One equation, one unknown. You all can solve. You all can solve. E value from here will be 0.663. E value from here will be 0.663. That is B option. Thank you, Satin. Thank you. Chaitanya 185.25. Yes, correct, correct, correct. Have you got this, guys? Have you got this? Then we'll be moving forward. Please like and share the session with everyone, guys. Let more students join the session. Let more students join the session, guys. Okay. Okay. Okay, Jai ma'am. Chaitanya. देखते हैं, let us see that can you solve the next question. What is gamma? See, gamma sat is given, water content is given. Gamma sat and water content is given. What is gamma D? Gamma D is gamma bulk upon 1 plus W. What is the actual meaning of gamma bulk? What is the actual meaning of gamma bulk? Gamma bulk means whatever the density of that particular condition. So here the gamma bulk will be 22 only. Here the gamma bulk will be 22. Gamma bulk does not mean that the soil is partially saturated. Gamma bulk means whatever the condition of soil, whether it is saturated, whether it is partially saturated, whether it is dried, whatever the soil is, that density is called as gamma bulk. Gamma bulk can be gamma saturated if soil is saturated. Gamma bulk can be gamma dry also if the soil is dry. So gamma bulk, many students think it is the partially saturated soil. No. Gamma bulk means whatever the existing condition, that density. So here the existing condition is saturated. So gamma bulk will be 22, gamma sat. So it is 22 divided by 1 plus 0.1, 1.1. So 22 upon 1.1 will be 20. So gamma D will be 20 from here. Correct? Yes, Chaitanya. Good. Let us see now, guys. This is a beauty of a question. This is a beauty of a question. Next question. It is asked in GATE 2023 in 2 marks. Take your time, guys. Take 2 to 3 minutes. Take 2 to 3 minutes and try to get the answer. Once you solve these kind of questions, you will gain the confidence. You will gain the confidence. This is blue color is water. This blue color is water. Okay, this blue color is water, and from yellow color let me make the soil. This is soil 1. Okay, green, and let me make with yellow color soil 2. Okay, sir, got it, sir. Now what they are asking, that the hydraulic conductivities of two soil are 10 and 1 mm respectively. Gamma W you have to take it as 10. Velocity head is ignored. Even if it is not ignored, in soil mechanics, what I told you every time, you have to close your eyes. You have to close your eyes and you have to write velocity head as 0. Because if the water is at rest, velocity is 0. If the water is moving, then in soil, if the water is moving, that moving speed is also very, very less. If in soil water is moving, that moving speed is also very, very less. Then also it has to be taken as 0. Okay. What is the total head at the junction at this point? Let me say the junction be, this point junction be J. This point be J. This point be J. What is the total head at J point? First of all guys, write this in your note or anywhere. Whenever it is not mentioned, the downstream end is taken as datum. Although guys, here it is taken 0 meter for this level, so this is the datum only by default. Otherwise, whenever nothing is mentioned, the downstream end, there are two ends, one is this, one is this, it is taken as datum. Now let me take a point here. This is 1 point. Okay sir, here it is as 2 point. Okay sir, this is J point, and let me take this as a 3 point, and I want to do now match between these points. Excellent question guys. You will learn a lot of things here. You will learn a lot of things here guys. Please focus. Please focus. Everyone, excellent question. Lots of question, lots of things will be cleared here. I want to do match now between these points. I want to find out the energy at each and every point. I want to find out the energy now at each and every point. See guys, here I am writing velocity head, here I am writing datum head, potential head, here pressure head, and here I will be writing the cumulative of all, that is total head of point 1, of point 2, of point 3. J we will do later on. Okay, J we will be doing later on. Okay sir, beautiful question sir. So velocity head, how to write? How to write velocity head in soil? Close your eyes and put 0. Close your eyes and put 0. Even they have mentioned that ignore the velocity head. Even they have not mentioned this line, still the velocity head in soil will be 0. Now datum head, what is the height of 3 point from datum? 0. 0 meter. What is the height of 2 point from datum? From datum the 2 point is 3 meter above. What is the height of 1 point from datum? 4 meter above. Now what is the pressure at 1 point? Guys, at 1 point you are applying a pressure of 10 kilopascal. At 1 point you are applying a pressure of 10 kilopascal. 10 kilopascal. But it is head, height. You cannot write kilopascal. So 10 kilopascal is how much height of water? Water pressure is gamma W into H. So 10 into H. So what is the value of H? 1 meter. So 10 kilopascal is equivalent to the pressure that is exerted by 1 meter of water. 10 kilopascal is equivalent to the pressure exerted by 1 meter of water. Yes or no? So pressure head will be 1. What is the pressure head at 3 point? 0. It is open to atmosphere. What is the pressure at 2 point? So due to water level is 1 meter. Water level is 1 meter. Due to water it is 1 meter, but 10 kilopascal is also exerting 1 meter. So 1 plus 1 will be equal to 2. 1 plus 1 will be equal to 2. So here it is 5, it is 5, it is 0. So what is the total head loss? From 2 point to 3 point, what is the total head loss? Total head loss is 5. Total head loss is 5. Now if I write, if I want to find K equivalent, okay, we know Q is equal to KIA. We know Q is equal to KIA. So first of all, let me write for the whole system. For the whole system, KIA. So we will write K equivalent into I into A. Okay, so what is K equivalent? it is H1 plus H2, height of soil 1, height of soil 2. Okay, what is K equivalent? It is height of soil 1 plus height of soil 2 upon height of soil 1 upon K1. K1 is 10 mm per second plus H2 upon K2. From here you can find K equivalent. Yes or no? That is H1 plus H2 upon H1 by K1, that is 10 plus H2 by K2. Yes or no? Yes or no? Into I. I am writing for the whole system. That is why I have written K equivalent for both soils, for the whole system. For the whole system, what is I? Head loss by L. So what is the total head loss? From here to here, what is the total head loss? 5 upon total length of the soil. Total length, I am writing this expression for the whole system. So total length of the soil is 2 into A. Now same discharge, I am writing only for soil 1. Same discharge, suppose I am now writing for soil 1. Same discharge. Suppose I am writing for applying the formula only for soil 1. For soil 1, I will be writing K1. That is 10 into head loss of soil 1 into length of soil 1. That is 1 meter into A. From here A to A cancelled. We will be getting HL1 as 0.4545. So loss in soil 1 is this. Okay guys, at the entry level, at 2 point, what is the total head? 5, and loss is 0.4545. So total head at J, at the entry level, water will be going downward now. At the entry level, what is the head? 5. And how much is lost? 0.4545. So the answer will be 4.54 meter, and you will get 2 marks in the examination. And you will get 2 marks in the examination, guys. Answer is 4.54 meter. Yes or no for this beautiful question? Yes or no for this beautiful question, guys? Come on, everyone. Please put a heart sign on the comment box if you got it. Please put a heart sign on the comment box if you got it, guys. Everyone, please. Everyone, please put a heart sign on the comment box if you got this concept. If you got this concept, guys, please put a heart sign on the comment section. Got the concept? Super duper concept, guys. Okay, guys, this will be tomorrow. Tomorrow 8 p.m. live session, guys. 25 topics that are important for GATE and 25 topics that can be skipped. Let me once again tell you the schedule. 18th there was no class na. From 19th again the surveying and then hydrology will be coming. For 18th we will be doing this. Okay. Okay guys, next question of consolidation chapter. Next question of consolidation chapter, guys. What is this chapter? Oh sorry, what is this question? Identical loads are applied. Identical surcharge are applied at ground surface at site X. This is site X. And this is site Y. Now guys, silt, clay layers are at X and everything is same. Soil is same. Only difference is at Y we provide a thin sand layer. At Y we provide a thin sand layer. Okay. Now the thin sand layer at Y is applied. If primary consolidation at X is estimated to be completed in 36 months. Here if it is taking 36 months. So how much time it will take here? How much time it will take here? Guys, this will be a one-way drainage. Only the water can go above here. But this is a two-way drainage. Water can go from thin layer also. Similarly for this, water can go here also. This is a two-way drainage. In two-way drainage, how much time is taken less? 4 times time is less than as compared to single drainage. As compared to single drainage, in two-way drainage, 4 times lesser time na. So here if it is 36 months, then in two-way drainage, because of this thin sand, this is two-way drainage, it will take 4 times lesser time. 36 by 4, that is 9 months. That is 9 months. Give me yes or no. Give me yes or no, everyone. Give me yes or no, everyone. Fast, 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 guys. Come on. Great, great, great. Many students do it correct. Vaishnavi did it correct. Okay, now this question, 2021, 2 mark. Let me check who can do fastest. Let me check who can do this fastest. Your time starts now. 3, 2, 1, go. I want to see in the comment section that which student can do this question fastest. GATE 2021 2 mark question. GATE 2021 2 mark question. I am waiting for your answers in the comment section. In a triaxial stress, this is volumetric strain on y-axis and the shear strain on x-axis, and the graph is drawn. Which graph P and Q represents which kind of soil, and I will be telling you the logical answer. I'll not be telling you to remember this. I'll be telling you the logical answer for solving this, or why the graph is made like this. Why the graph is made like this. Come on, everyone. Come on. Vaishnavi, Chaitanya, Avinash, Sachin, Jamim, Arna, Nikita, I want answer. Let me check who can do this question fastest on the comment section. Come on. Come on, come on, come on, everyone. Hit this. Yes, Vaishnavi has given answer. Maybe correct, maybe wrong. Other student, please also give. Answer. Chaitanya also has given C. Guys, see, this graph is for loose sand. And loose sand behave as a OCC clay. And sorry. This P is for dense sand. I will tell the logic. And dense sand behave as a OCC clay. And Q is a loose sand. And this behave as a NCC. C option. Now let me tell you the logic. Guys, in dense sand, this is minus and then plus. What happens in a dense sand if I apply the load in a triaxial test? In dense sand, if I apply the load, initially the volume will decrease. So it will be minus. Volume will decrease. Minus. Dense sand, it is going downward. Minus. Volume will decrease. Minus. And suddenly, because it is very dense, voids are very less. Further, if I apply the load, it will crush, it will break, or वो फैल जाएगा फिर, then it will spread. Initially, the volume will decrease, but at one time, because it is already very dense, it will break, it will crumble. Okay, then it will spread, then volume will increase after it breaks. Okay, but in loose sand, very voids are there, much amount of voids are there. I apply the load, it will continuously decreasing the volume. It will continuously decrease the volume. Okay, loose sand. Got the concept? Yes. The most appropriate triaxial test to assess the long-term stability of an excavated slope. Long-term stability. Guys, in long-term stability, which type of test should be done? Even if it is excavated slope, which type of test should be done? Please tell me, everyone on the comment section. It should be CD test na yaar. Consolidated drained test. Because after a long time, all water has been expelled out from this. So consolidation, drainage, everything has happened. So it will be CD test for long term. Okay. Yes, this is MSQ. Now let me check who can do this here. Let me check who can do this question. A group of 20 piles, 4 rows and 5 columns. 4 rows and 5 columns. This is the pile. D is 400 mm, spacing is this. So D is 0.4 meter, diameter of the pile, and center to center spacing is 1000 mm, that is 1 meter. Converse Lagrange formula has to be used. Single pile capacity is 380 kilonewton. What is the group efficiency? Do you remember this formula? This has been asked in GATE. What is theta first of all? Theta is calculated as, guys, what is the theta? Tan inverse D by S. Tan inverse D by S. So theta is tan inverse, diameter is 0.4, S is 1. So theta value from here is 21.8 degree. If you don't know the converse Lagrange formula, please see here. Now what is the efficiency formula as per this? The group efficiency is given by 1 minus theta by 90 into M. M is number of rows, N is number of columns. n minus 1 plus n m minus 1 upon m into n, m into n. M is number of rows, n is number of columns. So 1 minus, this is group efficiency, this is the group efficiency as per this formula. So m value is 4, n is number of columns. So apply the formula, 4 into 5. So from here the group efficiency is 62.5%. From here group efficiency is 62.5%. So what is the capacity of pile group? Now it becomes an aptitude question, yaar. Capacity of group. Now it becomes a aptitude question. So what is the capacity of one pile? Capacity of one pile is 380. So what is the capacity of 20 piles? 380 into 20. There are 20 piles, na? 1, 2, 3, 4. 4 into 5, 20 piles. So this is the capacity of 20 piles when efficiency is 100%. But here the group efficiency is 62.5%. So it is 62.5%. So what is the value that you are getting from here? 4750. 4750 kilonewton. So this is the answer. Okay. Efficiency of pile group is 62 and capacity is this. So answer will be A comma B. Answer will be A comma B. Yes or no? Everyone, please tell me, yaar. Come on. Please tell me. Have you got it? Have you got it, everyone? Have you seen this formula first time, or have you already prepared for this? Or you have prepared for this, guys? Come on, come on, come on. Okay, okay, okay. Let us move to the next question. Let us move. Everyone, please write down your cities here. From which city? Every day we are meeting at 8 p.m. Na? Yesterday we have done strength of material practice. Today we have done soil practice. Tomorrow we'll be doing the 20 important questions, concepts of gate that should be studied, and 20 that can be skipped. Then day after tomorrow again we are starting surveying. Please write down the cities, everyone. Everyone write down the cities on the comment section, guys. Puducherry, Salem. Okay, okay, okay. Let's move forward then, na? Okay. In the general shear failure, it is local shear failure. Failure is sudden. No, it is in general shear failure. General shear failure, the failure is sudden. It is here for the compressible soils. Okay, large settlement is done. Okay, if you see the load settlement graph, na, load settlement graph, then for general shear failure it will be like this. Suddenly it will fail here. But for local shear failure, na, the graph will be like this. So more settlement, large settlement. And here the Rankine passive zone is developed imperfectly. So it will be B, C, D. B, C, D for this MSQ question. For this MSQ question, it will be B, C, D. Okay, okay, okay. Got it, everyone? Yes. Now, two soil profiles are used as backfill. Gamma is written for both 15 and 20. Find the resultant active earth pressure. So what is Ka1? 1 minus sine phi, 1 plus sine phi. Please check, it will be coming 1 by 3, I guess. It will be 1 by 3. Similarly, calculate Ka2. Similarly, calculate Ka2. Everyone. Everyone, guys, and tell me 1 minus sine 40 upon 1 plus sine 40. 1 minus sine 40 upon 1 plus sine 40. Tell me the value. One minus sine 40, 1 plus sine 40, it is 0.277. 0.217. Now let me make the diagram. Now everyone please see the diagram. with yellow color, let me make. So it will be starting from 0 na, and here what will be the value? Here what will be the value? It is Ka1 into gamma h. Ka1, that is 1 by 3 into gamma is 15 into 2, that is 30. So 30 by 3, it will be 10. It will be 10. This point will be 10. Ka1 into gamma h, this will be 10, and just below it will be same, just below it will be same, horizontal stress is same, 15 into 3, 15 into 2, 30, but it will be multiplied by 0.217. It will be multiplied by 0.217. It will be multiplied by 0.217. Yes or no? Yes or no? Tell me yaar, come on. Tell me. So this value will be Ka, that is, let me call here this value is alpha. That is done, this alpha. What is alpha? For soil 2, it will be Ka2, 0.217 into gamma into 15 into h, that is 2. Okay, then here this is alpha. Then here what is, let this point be beta. What is beta? That is in soil 2, so it will be multiplied by 0.217 into K into vertical stress. What is vertical stress? 15 into 2 plus 20 into 2. So you will be knowing now this point. You will be now knowing this point. This point is 10. This point is 10. This point is alpha. Alpha value is known here. And this is beta. Now from all this, what is the resultant pressure? Total pressure. What is the total pressure? So here the total pressure is suppose PA1, and here the total pressure is suppose PA2. So total pressure PA total is PA1 plus PA2. What is PA1? It is average stress into area. So at the top it is 0. 0 plus 10 by 2 into area, that is 2 into 1. And what is PA2? Alpha plus beta by 2, average stress into area, 2 into 1. Now you can calculate PA1, you can calculate PA2, you can add both of them. You can add both of them. That will be, answer will be 31.7. Have you understood the concept? Have you understood the concept? Please tell me. Please tell me. Have you understood or not? Civilian Tamil. Got it? Okay. Now this. Surcharge load required to be placed on horizontal backfill of a smooth vertical wall, so to complete that, eliminate that tensile crack, that negative portion is not coming. What happens in a cohesive soil in active case? That is Ka into sigma V minus 2C root Ka. So what happens in a retaining wall now? If I write it Z here, for Z is equal to 0, that means at top level, sigma H is actually K into vertical stress. Vertical stress is gamma Z minus 2C root K. So actually for Z is equal to 0, this becomes 0 and sigma H becomes minus. Sigma H becomes minus. So the graph something becomes like this. At top, it is minus 2C root K. As we are going down, this positive value is increasing because Z is increasing. As we are going down, this positive value is increasing because Z is increasing. So this minus is eliminated. At one point it will be 0, and with more Z it becomes now positive. So this is the natural diagram. But now as per the question, what they are saying that we have to eliminate this tensile negative part. We have to eliminate this negative part. Okay. So how they are putting some surcharge now? They are putting some surcharge on the ground. Q. Okay, now what will happen? Now it is sigma h is equal to now guys, Q surcharge is applied. Please see here. So what is this vertical stress? Vertical stress is at any depth z, the vertical stress is Q plus gamma z. Q due to surcharge and gamma z due to weight of soil, minus 2c root k. And to eliminate the tensile crack, we want that even at the top level that minus should not be coming when z is 0. So sigma h should be positive or at least 0. Positive or at least 0 at even when z is equal to 0. It should not be negative like this. So KAQ minus 2c root KA. So from here the Q value is 2c root KA upon K, that is D option. Yes Chaitanya, Sakshi, good, excellent. Excellent. Give me yes or no. Okay. Now guys, take this as a homework. I want answers on the comment section. Now what is the maximum depth of unsupported excavation? Guys, see, whenever we excavate soil then after a certain level we have to put the bracings. Otherwise the sides will collapse. Why sir they will collapse? Because guys, the horizontal stress is like this horizontal stress. As we go down, what is the horizontal stress? K into sigma v. K can be Ka, Kp, K naught, anything depending on case. So vertical stress increases, so horizontal stress also increases. So as we go downward, horizontal stress increases. So due to more horizontal stress at the bottom, these sides may collapse like this inward. So we put the bracing, but this bracing has to be put after a certain height. That height is called 2z0, or that value is 4c by gamma root Ka. 4c by gamma root Ka. Because up to this 4c by gamma root K, net minus and plus become 0. This is z0 and one more z0. That net force here is 0. Minus and plus becomes 0. Net is 0. So up to this we don't have to put any excavation. Yes or no? See how many questions we had done. Only one question I have given to you homework. Okay. Now this is a top class question. This is a top class question for the top students. Top class question for a top class students. But before solving that, solve this MSQ. Then we will be doing that question. Before that, solve this. Then we will be doing that top class question. A timber pile of length L 8 meter, diameter 0.3 meter is driven with a 40 kilonewton hammer, falling from a height of 1.2 meter. The total settlement of the pile in last 5 blows is 40 mm. You know that there is a term S, that is average settlement in last 5 blows. So it is 40 settlement in 5 blows. So average settlement is 8 mm. S is 8. Now what is the load carrying capacity? So load carrying capacity is W into H into 6 into S plus C. So what is W? What is W? 40. Height is W is 40. Height is 1.2 meter. Okay. what is W is equal to 40. You can have to write this in proper units because that is empirical formula. Now you have to write W in a particular thing, kilonewton, height in, I guess, in centimeters you have to write. Okay, 6, you know. What is S? S is 8 mm. C for drop hammer, C for drop hammer is how much? 2.5, and for single acting steam hammer this is 0.25. So W you know, H you know, 6 you know, S you know, 8 mm. C is 2.5 for drop hammer and 0.25 for single acting hammer. So this will be 242 for drop hammer and 761 for single acting hammer by putting the corresponding values of C. Now this question, guys, excellent question, guys. A 4-meter wide strip footing, see, 4-meter, see, I make the figure so time can be saved. 4-meter wide strip footing, no need of application of shape factors. Okay, shape factors should not be applied here, it is strip footing. Depth of 1.8 meter in a C5 soil. Water table is at a depth of 5.8 meter. Okay, so water table effect will not be taken into consideration because we only go up to DF and then B, that is 4 meter. Water table is after that, so water table will not be coming into the picture. C is 35, phi is this, gamma sat is this, gamma bulk is this, gamma W is this. We will be using gamma bulk because soil is not saturated. Okay, now first is what is the NC, NQ and gamma value. Guys, as in this question, phi is less than 29 degree. So therefore local shear failure, and for local shear failure, what we do? First of all, we calculate Cm, that is 2 by 3 of C, 2 by 3 of 35. So this value, that is 2 by 3 of 35, you have to calculate, that is 23.33. Next thing, you have to calculate phi m. Tan phi m is 2 by 3 of tan phi. Phi is 28.63. From here, guys, phi m value is 20 degree. Now NC, NQ and gamma we have to use corresponding to phi m, 20 degree. That is 17.7, 7.4 and 50. 17.7, 7.4 and 50, that is B option. Okay. Now ultimate bearing capacity QU is CNC, ultimate bearing capacity, plus QNQ plus half B gamma N gamma. But we have to use NC, NQ and gamma, these values in this expression, and we have to use CM, not C, and NC dash, NQ dash and gamma dash. So CM is 23.33 into 17.7, correct, plus gamma is, it is not saturated, this soil is not saturated, we have to write gamma of this, not saturated, so that soil is bulk, so gamma is 17 into DF, 1.8 into NQ is 7.4 plus half B is 4 into gamma is bulk, that is 17 into N gamma is 5. So this value is coming to be 803.38, 809.38, I guess, 809.38. So this is answer C. Okay, now D, we have to calculate Q and U also. Q and U is QU, that is 809.38 minus gamma DF, that is 17 into 1.5. So this value is 17 into 1.8. DF is 1.8. This value is 778.7. And they have asked net safe. So Q net safe is QNU by factor of safety. Where is the factor of safety? Factor of safety is 2.5. So divided by 2.5, this is 311.5. So not 341. So answer will be B and C. Have you got it? Have you got it? Everyone. Great, great, great. So guys, new batches for GATE 2026. I will be taking per CPM from Thursday. You can join our app, join our courses. Okay, for 26 students, 2026 students, I am starting per CPM from the Thursday 19th 5 p.m. Thursday 19th 5 p.m. I am starting per CPM for GATE 2026. Game changer series is going on, guys. Soam we have done, soil we have done. Now tomorrow, day after tomorrow will be survey and then other subjects again at 8 p.m. It will be on YouTube, guys. But tomorrow will be this session. Tomorrow 18th will not be off. Tomorrow 18th will be this session. That important topics, 25 important topics and 25 topics that can be skipped. That I'll be taking today, tomorrow at 8 p.m. Then after that we'll be continuing with hydrology. Those students who are preparing for GATE 2025, they can have our crash course. You can download the resultant civil app from the Play Store. Every link is in the description box. You can download our app and join this crash course for 25. For 26 students, guys, we have a detailed course. For every subject, classes will be there, live and recorded. For every subject, PYQ. For every subject, formula book. For every subject, you will be getting study notes. For every subject, you will be getting workbook, includes MSQ question. Live plus recorded classes. For GATE 2026 on 27. You can download our app from the Play Store. Okay, you can write resultant civil, download our app from the Play Store and get it. Okay, for any connection, guys, you can connect me here directly here. This is my personal number. You can connect me in this. You can WhatsApp here 935491630, or you can mail me at abhinav@resultant.in. Okay, thank you. Thank you everyone, guys. See you tomorrow in this session 8 p.m. on YouTube. Thank you everyone, guys. Thank you all. Please subscribe the channel for more such sessions. Thank you everyone.